All right, for today, we are going to talk about graphing radical functions. So we're going to make some work here with XY tables. So we're going to graph a radical function, and I'm not really sure if you guys ever seen one before. But basically, a radical function, if this is your coordinate grid, it's going to give you this kind of shape that's like this. So if you see a graph that's like that, that's going to be a radical function. And it's a radical function because it has a square root, and it's asking you to graph this square root. Okay, so when we start off with, and we start making XY tables, it's the same concept as what we've done before. You choose your numbers to plug in for X. And eventually you'll kind of learn some tips and tricks to help you pick better numbers that will maybe form your graph a lot quicker. So in the middle there, that's the equation, and then my output. So my input, the equation where the work's going to go, then my output. I always like to start with 0 if I can use it, because it makes things really easy. So if I'm plugging in 0 for X, it's saying what's the square root of 0? Well, the square root of 0 just equals 0. So 0, 0 is going to be a point. Okay, if I plug in 1, let's say. So come over here. What's the square root of 1? Well, that's 1. So I plugged in 1, out came 1. All right, now if I plugged in 2, for example, so the square root of 2. Well, the square root of 2 is not going to be something that is easy to graph per se, because it's not going to be a whole number. I can still figure out what it's going to be. Type in the square root of 2, and it's about 1.4. So I can estimate where it'll be. Come over to 2 and about 1.4, roughly in there. So I'm thinking, well, what could I possibly plug in maybe to get some whole number answers? Well, not 3. What about 4? Because the square root of 4 is going to be equal to 2. So when I plugged in 4, out came 2. And then if you look along here, you got 5, 6, 7, 8 to choose from. And I'm thinking, the square root of 5, not a whole number. Square root of 6, not a whole number. Square root of 7, not a whole number. All right, but maybe I'll just kind of stretch it out. Maybe I'll use this 8 here just to give me another valid point over here. So 8, and take the square root of 8, and it's about 2.8. So when I plugged in 8, see there's 2, almost all the way up to 3. And then what we do is we just connect this curve. So it's going to be curved, kind of like what we did parabolas. We had to estimate where the curve is going to go. And then we have to put an arrow on the end so that it will continue in that pattern forever. So it's going to, slowly keep increasing. It's not going to be real drastic. It's not going to come back down. It's just going to go in that pattern there. So that's a radical function. That's the square root of X. Perhaps the most simplest one to graph. All right, so now I move on to number 2. And number 2 says, let's graph y equals 2/3 times the square root of X. Okay, so if I'm going to graph 2/3 times the square root of X, I'm going to set it up like I did before, X. And then in the middle, if I want to just put this piece back there, that's fine. So that's my 2/3 root X. And then out here is my output, my Y. So I'm thinking I could definitely use 0. 2/3 times the square root of 0. Well, the square root of 0 is 0 times 2/3. That's still 0. So I'll actually move it over here a little bit so I can graph these. So 0, 0 is my point. All right, if I plugged in 1, so I have 2/3 times the square root of 1. Okay, so square root of 1, let me move this a little bit. Square root of 1 we know is 1 times 2/3, you get 2/3. So I plugged in 1 and I got 2/3, so I'll go try to plot that point about so. Okay, let's say maybe I try 4. So 2/3 times the square root of 4. So the square root of 4 is 2. 2 times 2/3 gives you 4/3. So 4/3 reduces to 1 1/3. So at 4, you're at 1 1/3. All right, let's get another point in there. Let's try 6. So 2/3 times the square root of 6. That's going to be kind of messy here. So I'm going to enter it like it says, 2, ABC 3, and then I'll put parentheses for my multiplication. Square root 6, closing parentheses, and I get about 1.6. Or almost 1 2/3. So at 6, we're at 1.6, a little over halfway there, about like that. So you see it's not as steep. It's kind of hugging the x-axis a little bit more. So go ahead and just kind of estimate how it's going to go. Put your arrow on the end, and that's that function. All right, number 3. We're checking out number 3. We got the square root of x minus 3. So now we got an extra piece here, that little minus 3 in the back. So square root of x. In the middle here, I'm going to do square root of x, take away 3. And then y is my output. All right, so I'm going to use 0. Square root of 0, take away 3. Well, that's 0. Minus 3 gives you negative 3. So when I plugged in 0, I got negative 3. All right, let's try 1. So the square root of 1, take away 3. The square root of 1 is 1. Take away 3 is negative 2. So at 1, we're at negative 2. So we'll notice this radical function here is, you see it's starting to make that curve there, and it's below the x-axis at this point. All right, let's try 2. So the square root of 2, take away 3. Because the square root of 2 is not a whole number, then I'm going to use my calculator. So square root of 2, and then take away 3. Oh, and see what it said, domain error, because I didn't put a parentheses on there. Take away 3, and it gives you negative 1.58. So if you get a domain error, it's probably because you typed something wrong in your calculator, like I did. You didn't use the correct parentheses. Okay, so about negative 1.58. So 2, go down negative 1.58, roughly there. All right, and let's go all the way out to 6. So the square root of 6, take away 3. So let's do that again. Square root of 6, put my closing parentheses, take away 3, and we get about negative 0.55. So at 6, a little bit below halfway, right, like so. All right, go ahead and connect it. So this is your starting point. And so on. If you'll notice, everything that I've done so far has been starting with a 0. And that is a good starting point. So this graph, all these graphs, they don't continue from here. This is the stopping point, stopping point, stopping point, but it does continue moving to the right positively along the x-axis. Number 4. So I have the square root of x plus 4. Okay, so make your xy chart here. Square root of x, square root of x plus 4, and then we get our y. All right, plug in a 0. Square root of 0 plus 4, well, that's 0 plus 4 gives me 4. So at 0, I'm all the way up at 4. Let's try a 1. Square root of 1 plus 4. So square root of 1 is 1 plus 4 gives you 5. So at 1, you're all the way up to 5. Okay, let's try a 2. Again, I know that's not going to be a whole number there. So I'm going to do square root of 2, closing parentheses, plus 4, and I get about 5.4. So at 2, I'm very close to about 5.5. Okay, let's try 6 now. So square root of 6 plus 4. So second, 6, closing parentheses, plus 4, and it's about 6.4. So at 6, we're all the way up to about 6.4, like so. Okay, estimate the curve. It's going to continue on, like so, and there's that one. I don't know if you've noticed any patterns yet, but there's definitely something going on here. And maybe you'll see with this next couple questions a new pattern arise. All right, square root of x plus 2. And notice this is all underneath the square root symbol. Okay, so I'm going to do my x. And then I have the square root of x plus 2. And then my y. Okay, if I plug in a 0, like we've been doing before. So the square root of 0 plus 2. Well, 0 plus 2 is just 2, so we're doing the square root of 2. So square root of 2 again is about 1.4. So I plugged in 0. This time I got about 1.4. All right, let's say I try 1. So it's now the square root of 1 plus 2. Well, that's going to be the square root of 3. So second, square root of 3, and we get about 1.7. So at 1, we're at 1.7-ish. Let's try 4. Again, you could choose 2, you could choose 3, you could choose 4, whatever you want. So 4 plus 2. I know that's going to be the square root of 6, which we've seen multiple times, and that gives me about 2.4. So at 4, I'm up to about 2.4. And then let's go with 8. So the square root of 8 plus 2. So that's the square root of 10. And we get about 3.16. Okay, so 8, I'm all the way up to 3, just a little past 0.16. All right, now go ahead and try to make that curve. And then that's that radical function graph. For the sake of time, I think we'll go ahead and skip number 6. And let's go to the next page. Okay, so the next page is really going to put things kind of together here. We got, this one's really a lot more complicated because we got numbers inside, we got numbers outside. But honestly, it's just doing some XY tables. That's it. Okay, so x. And then our equation is 2 times the square root of x minus 2, all that's underneath, and then take away 1 to get our y value. So I'm going to use 0 again, 2 times the square root of 0, take away 2, and then minus 1. All right, if you plug in a 0, take away 2, so you got 2 times the square root of negative 2, and then you get negative 1. But look what happens here. You get the square root of negative 2. So even if I enter that, 2 root negative 2, closing parentheses, minus 1. Let's see what happens. And it gives you that domain error. In this case, we did not type it incorrectly, but something should have went off when you saw this negative under the root symbol. And that means there's no solution. You can't do that one. Okay, so there might be other numbers that you guys need to plug in along the way, because that's telling you that 0 is not part of that function. So it's not going to work there. So I need to keep thinking, well, if 0 is not going to work, let's move further to the right on the x-axis. Okay, so in this case, let's try 2. So 2 times 2 take away 2 minus 1. Now the reason I chose 2 was because if I would have plugged a 1 in there, well, 1 take away 2 still gives you negative 1. So I know that one's also going to be a no solution. All right, but if I plug a 2 in, 2 take away 2, that's 0. And the square root of 0, you can actually solve that. That's 0. 0 times 2 is 0. And then you have this minus 1. So if I plug in 2, you get negative 1. Okay, so that's going to be my starting point there. Let's say now I plug in a 3. So 2 times 3 minus 2 under the radical symbol, take away 1. So 3 take away 2 is 1. The square root of 1 is 1. Times 2 is 2. Then take away 1 gives you 1. So when I plugged in 3, I got 1. Okay, if you notice this one here, it seems to be progressing way faster, but it's still got this little curve going on here. All right, let's try, I don't know, 6. So 2 times 6, take away 2, minus 1. Now I chose 6 because I know 6 minus 2 gives you 4, and that's a perfect square. So square root of 4 is 2. 2 times 2 is 4. Take away 1 is 3. So I plug in a 6, and I get 3. So now I'm going to do just one more point. Let's do an 8. Okay, so 2 times 8, take away 2, minus 1. All right, 8 take away 2 gives you the square root of 6. So I have 2, and then the square root of 6, closing parentheses, and then minus 1. And we get about 3.89. So you plug in 8, you get about 3.89, very close to 4. So that'd be up here like so. Okay, so that's my starting point. So it's going to progress like so. And that's the graph of that radical. Okay, we're also going to skip number 8 for the sake of time. So you guys now go ahead and solve number 9. Do number 10. Number 11. 12. 13. 14. 15. And last, 16.